Good. Cool. So yeah, I'll introduce myself and then talk about LifeOmic a little bit. So I'm Taylor Steinberg. I am a data engineer here at LifeOmic. It's my official role. It's more or less just software engineering, but I focus on the data more than anything. I have a background in computer engineering. I grew up in South Carolina, went to Clemson University, migrated up here a couple years ago. So when I was there, I was doing robotics and took a class in distributed computing my senior year, and that's kind of what gravitated me into this field. I've been working in healthcare for my entire career, which isn't that long, but I worked at a company called Premier before I started LifeOmic. And while I was there, I was doing a lot of predictive analytics and doing causal modeling. But a lot of that work was doing data transformations in Spark, pulling data out of different databases. And
is it a hospital database?
Yeah, it was hospital databases.
Okay.
Yeah. And then, yeah, like I said, I've been doing a lot of distributed processing. Most of it's been in Spark. Before that, I did a little bit of MPI when I was in school, which is like really academic stuff. And I've been doing a lot of work with databases. I use Elasticsearch here, Postgres, MySQL. I've done Netezza in the past. I haven't had to deal with Oracle, thankfully. But yeah, lots of experience there. And then there's my GitHub, if you want to follow me. I actually work on some open source projects now, so I'll actually promote that a little bit. And then LifeOmic, so we're a precision healthcare company. We have 3 different products. The one that everybody from LifeOmic that is here works on is called the Precision Health Cloud, which is basically a platform for doing healthcare genomic centric analytics, more or less as a service. So we work with IU, School of Medicine, Regan Street, and a couple other customers. I'm helping them process genomic data and optimize it. And then we also have the intermittent fasting app, if anybody's into that. It's a mobile application to help you track your intermittent fasting. And then we also have a whole security product as well that I won't go into. But if you're interested in that, feel free to talk to me afterwards. So outline for today, I'm going to do a little getting started. I'm just going to do a brief amount of code. A lot of this is just going to be focused on Spark and understanding Spark. But we'll do a getting started, just showing you how to get going, familiarize you with the syntax a little bit. I'll do a quick history lesson on Spark because I think it's kind of interesting and just good to know how things evolve over time and how we end up where we are. And then I'll go into the Spark architecture, which I think will be really great for anybody that's not familiar with distributed computing. Then we'll talk about RDDs and DataFrames and Datasets MI, which are the different API layers that Spark offers, which can be really confusing to a newcomer. I would hope to clear that up. Then we'll talk about cluster managers, and then we'll talk about libraries. And then at the end, I'll just kind of give some of my biases to close out, and then we can do Q&A if we have time. Sound good? Awesome. Cool, so getting started. So if you want to get started after this, just using Spark, if you've never touched it before, if you have a Mac, the easiest thing to do is just brew install Apache Spark. If you have a Windows computer or a Linux machine, there's equivalents to those. You guys know what the best ones are for that. But once you start it, you just install it. You just run Spark shell, and this is going to boot up an interactive shell that you can start messing around with Spark. So the one that I'm showing today is the latest version, 2.4.2. So the quick tutorial I'm going to go through is just a simple program that counts the number of unique words in the book Beowulf. So I pulled down Beowulf because I was trying to find something that was completely open source, and I went to WordPress, and there it was. So I pulled it down, booted on my Spark shell, and then this is kind of the first bit of Spark code we're going to look at. So that top line, I'm just reading that text file Beowulf into a Spark dataset that I've called Beowulf. So for people that aren't familiar with Scala at all, that val there is just saying I'm creating an immutable variable. Right? That's a dataset that has a type string. The variable is called Beowulf. And if we were to look at that using the Spark dataset.show method, we can see what that contains, which is a data set that has a single column, and each one of those rows in that column is a line from that text file. So the goal of this is to count the number of distinct words, right? So the first operation we need to do is we need to do a flat map and split on empty white space. This is one way to do it. So if you're familiar with flat map from Scala, it's essentially, well, when I do line.split, that's going to take every line from that previous slide and split it into an array or sequence. With every word, split it on white space. And then the flat map is going to say, you take those arrays and then flatten them out, so then I just have a single list of those. Ross can probably explain that way better than I can. That's how I think about it in my head.
You've been doing it longer than me.
Okay, yeah. So what we end up with is a new data set that has every single word from that text file on its own row. So as you can see here, we still have white space characters in there I didn't catch. That's okay. So the next thing we need to do is we want to sort that and then find the distinct. So the value there for words.sort, that value is saying use the value column from that data set, right? So this column right here, value, is what I'm referencing in the sort. And then off of that, I'm just calling it distinct. So that gets us down to a data set that has the distinct words, white space things in the text file. I'm just showing the top 10 over here. So if we run a count on that data set, we get the full size of that, which is 11,992.
So we put val the big data set, but here we are not counting that particular data set, right? I mean, so how does it know that? Oh, sorry, you put the name distinct. I got it. Okay.
Yeah, so
okay.
I call it distinct.
Okay, got it.
I don't always
sorry.
use that. Yeah. So we use val. Whenever I write Scala, I try to keep everything immutable. Sometimes when you're using Spark, since you're just typically appending transformations onto the same data set, it can be okay to use a bar just because you're copying things. But for the sake of just using immutability, use the val. So if you look at this all together, on the left side of the screen is each of those previous lines I showed. Read the text file, flat map it, sort it by value, do a distinct count. That's technically equivalent to the bash script that I have on the right. So people that are familiar with bash, that first line is like catting it, and then I'm splitting it, and then I'm sorting it, and then I'm taking the unique values and then doing a word count. So if you run those, you get the same result. So you may be wondering, well, why would you do this in Apache Spark when I could just do it in bash? Yeah, don't read a single text file in Apache Spark. That's not what it's built for. Apache Spark is built for doing really big distributed data processing. If you wanted to count all of the unique words in every single book on Gutenberg.press, you could do that with Apache Spark. If you wanted to count all the words in Wikipedia, then you would want to use Apache Spark because you need to distribute it over lots and lots of machines. It's not going to fit our computer. It's not something you can do with Bash. So that's when you want to use Apache Spark. But for the sake of simplicity, there's a decent example. Cool. So that's pretty much all the code I'm going to go over. But keep that in your mind as we're talking about these other things and try to think through how that would execute in Apache Spark. So a quick history lesson. Apache Spark's been around since 2009 is when it was incepted. PhD student out of UC Berkeley started working on it. Had a lot of success with it. He published a paper in June 2010 called Spark Cluster Computing with Working Sets. It's available online. I recommend reading that if you are brand new to Spark. It just kind of gives you a good introduction to what it is and where it came from and why it exists. On June 12th, 2012 was when they released version 0.5, which was kind of the first version that you could try to use in production. Although you're pretty cutting edge if you tried to at that time. That was kind of the first stable version that existed. About a year later, it was donated to the Apache Software Foundation. And not long after, well, of course it was relicensed under Apache 2. But not long after, it became a top-level Apache project. It got really high adoption, really fast, and a lot of people started working on it. So in May 2014, Spark SQL 1.0 was released, and this kind of took Spark to a whole new level, because this is the introduction of the Spark SQL library within Spark, which made it easy to use Spark as if you use any other type of database. It had a SQL interface, which I'll go over later, but it made it very accessible to anybody who's done SQL in the past. So at this point, things really started to take off with Apache Spark. This is when you started hearing Cloudera and everybody else started trying to sell it to you. Yeah. So people kept working on it, and in 2016 and on July 7th, they released Spark 2.0, which is the current major version. And that introduced the Dataset API, which came with a ton of improvements for speed. They rewrote a large layer of abstraction that has to do with how they serialize these objects when they're passing them around, which just really, really sped up everybody's applications. So that was a really big milestone. And then as of April of this year, they released version 2.4.2, which is well identical. So that's the version I was running earlier. So a really quick history lesson. Any questions so far? Okay. Yep.
If you email us these slides.
Yeah, I can put these slides on the Meetup. Yeah, yeah. All right, so Spark architecture. So again, Spark is a distributed processing engine. So I'm going to start getting into how Spark how the topology is oriented, and try to familiarize you with some of the concepts of distributed computing. So this is the basic topology of a Spark program. There's a bunch of different parts here. I'm going to break them all down. But the main things to realize is we have kind of three distinct components here. We have on the left side the driver program with the Spark context. This is commonly referred to as the master node. This is where your Spark program runs. This is kind of the head honcho. This is what coordinates everything for your Spark program. On the far right side of the screen, we have two worker nodes. These are the things that are doing all the work. They're doing all the execution, right? You can have as many of these as you can get a hold of. You can scale this indefinitely. There's just two listed here, but you can imagine they're just going out to infinity. Right? And then in the middle is the cluster manager, which is a part of the Spark ecosystem that sits outside of the core Spark framework. The cluster manager is something that you plug into that helps you coordinate resources. So the cluster manager can be something like Hadoop Yarn, it can be Kubernetes, it can be Apache Mesos. There's also different cluster managers you can use, and I'll go into that more later. So breaking all these things down, there's the driver program. So again, the driver program is what you're executing. So that chunk of code we looked at before at the beginning, that would be the driver program, right? And that would live on the master node. And that master node contains the Spark context. That Spark context is what has all the information about how to connect with the cluster manager, how to pass information to the worker nodes. It has information about your JVM settings. It has information about timeouts, networking. All those things are in the Spark context. That's what organizes all the intricacies of your program. And that communicates directly with the cluster manager and communicates with the executor nodes. Which I mentioned here. So the Spark context is not the driver program, the Spark context is what does these things. So, and then in the middle, we have the cluster manager. And as I said before, it's an external service. It's used for acquiring resources, and it manages the workers, right? It coordinates with the Spark context, and I'll talk about this a little bit more later. And then on the right side of the screen are the worker nodes. And again, these are the things that run the application code. So when you're doing a flat map string split, that is actually occurring on the worker nodes. It's not occurring on the driver program. It's occurring on the worker nodes. But if you're doing a print, like the show method I was showing before, that was being run on the driver node, because that's something that's on the front side of your program, right? That's something you're interacting with directly. Every worker node can contain multiple executors from different driver programs. This is a really interesting concept to think about. So if you have a cluster manager like Hadoop Yarn or Kubernetes that has lots and lots of different machines, you can have multiple Spark programs using different executors on the same machines, right? So if I have a box, I can have 5 different programs running on there simultaneously. They each have their own independent executor, right? But they're all being coordinated by the same cluster manager. And then the executor, right? The executor, which is the thing that has the resources, it's assigned to the application, and it does the memory allocation, it does the interfacing with the disk, and it can communicate between executors. So remember, we can have n number of these things, n number of these worker nodes, n number of executors, and the executors are going to do a lot of the work, a lot of the data passing between them, right? So if you wanted to, if you need to shuffle data between multiple workers, the executor is a thing that's coordinating all that. And then the task inside of the executor, that's the actual unit of work. So that flat map operation, that's actually occurring in a task that the Spark program has figured out where to put it and how to run it, right? And then finally, there's the cache. So this is something you'll stumble across when you start working on Spark programs. You'll see people that are saying, oh, you should put your memory, you should put your data set in cache. And you're probably like, okay, what does that mean? I don't really understand what it's doing. So the cache can be both memory and disk, depending on how how you set it up, how you configured it for your job. But it's important to know that the cache is something that can be shared between tasks. So if you have something like a metadata data set that was pretty small, like a couple megabytes, and you wanted to share it between all of the tasks that are running, you could cache that, and it would make it a lot faster for your application because it no longer has to shuffle between nodes to find it. It's just cached onto every single machine, and it can just look it up. So that's why it's useful for querying small, hot data sets. Okay. So in summary, just another way to hear this. So a Spark program runs on a master node. It executes a Spark context that communicates with the cluster manager, right? And the cluster manager coordinates many worker nodes, and each of those worker nodes runs an executor that runs multiple tasks. Okay? That's all the pieces. Let's stop there and let people ask questions. So does anybody have any questions about that so far? Try to wrap your head around it.
We were talking about the cache. Like, is that represent, like, you create one cache and then Spark takes care of distributing it across? Is one that's shared across all? Not shared, but is it distributed by Spark across all the worker nodes? Yeah. So there's a cache on every worker node, right? So every worker node has 2 gigabytes of memory that's reserved for the cache, and Spark uses the cache to save a particular piece of information that you want to share, that you want to be replicated across every single worker node and not partition. So a really large data set, something that's like a terabyte, the first 10 gigs are going to be on one worker node, the second 10 gigs are going to be another worker node, right? It's going to be split up across all of them. But the cache is something that's replicated on every single one of those, right? So if you had a really small data set, like a 10 megabyte data set, you don't want that just living on one node. You want to cache across everything, so it's easy to find or faster. Yeah, it's a good question.
You can make a lot of changes to the cache, or those account for the replication. Is that not what you do?
Yeah. What would you mean by changes?
You wouldn't write the cache as part of your job, or would you just write to it at the beginning?
Yeah, typically when you're using the cache, there's a spot in your code that you have a data set that you know is small, want to be in there, whether that's at the beginning of your program or the middle of it. And then you say, hey, this data set cache it.
So you're not using the same state.
No, you're not using the same state. That's a different concept.
Yeah.
You can serialize your state for your Spark job into a file, so then you can boot it back up from that state at a later time, which I didn't cover. But that's a good question. Anything else? Yeah.
mentioned, not very technical. What is the implication of using Apache Spark on the hacking safety perspective of HIPAA, all these law, and the impact on your company's insurance?
Oh, right.
Right.
So, the question was, what's the implications of using Spark on top of healthcare data or HIPAA data, PHI data? So security kind of lives outside of this whole talk, more or less. It's important to have good security around the programs we're running, right? For us at LifeOmic, we encrypt all of our data at rest. We encrypt all of our data in transit. All of our Spark jobs are running under their own IAM permissions, so they're siloed. You can't connect directly to them without the right credentials. So that's another additional layer on top of this. Spark has support for encrypting traffic built into the system, like you can do SSL. But that larger question really sits outside of just Spark.
And that's why Databricks is more, they have HIPAA compliance right now, right?
And, yeah, AWS does as well, so they have HIPAA compliance for EMR.
Insurance premium, if you subscribe to AWS, insurance is going to probably double. They say, well, it's more vulnerable. More likely, you get attacked by.
Yeah, I mean that's really.
We are kind of debating. We have probably 100 million patients with medical records. But we dare to put anything on them. And clouds or connections because.
Yeah, I went through that same thing in my last company. Yeah, I definitely know where you're coming from. We ran all of our own infrastructure and all of our own stuff, and people were really worried about going on the cloud. I would say it's you have to have the right people that have the technical know-how to do security in the cloud if you want to move in that direction. It's important to have people that understand the risk of being in the cloud, but it's totally doable. You can do it in a really safe way if you know what you're doing.
Have you heard anything any business that be actually booted by
no
hacking or in the spot?
No, not that I've heard of. Most of the healthcare hacks that I've heard about, I don't know, but anybody else has heard have been people running their own data centers that get hacked. Typically, just because so many people are using AWS, when something's HIPAA insured, it's safe because there's a lot of cloud over there.
You mentioned that show runs on the driver node, and then the flat map, I suppose the splits, those would operate on the worker node. When I've done Spark, I've had just a horrible time developing intuition of what runs where. Is there any guidelines so you know which one? I could take a semi-educated guess, but I was wondering if you knew.
Yep, so there's kind of two things I think about. One is to do something like a show, you have to collect it back to the driver node. So anytime you're doing a collect operation, that's going to be coming back to the master node, right? So in order to do a show, I have to actually physically bring the data from the worker nodes back. So that's one way I think about it. The other thing I think about is when I'm actually implementing programs that are writing to databases, is thinking about how to avoid bringing things back to the master node, right? And the best way to do that is if you're operating within a data set closure, like if you're running for each or you're running a map, typically those are always happening on the master node. It's only when you're doing on the worker nodes. It's only when you're doing a collect operation that it's actually coming back. So yeah, the rule of thumb is collect and show. And if you're bringing things back to like an actual Scala list from a data set, that's going to be going down to the master node.
My guess is going to be if it returns a data set, it stays on the workers, and if it doesn't return a data set, it's not.
Yeah, that's a perfectly valid way to think about it. That will almost always be true. That's a good question. Cool. Anything else? Awesome. Cool. And then talk about cluster managers for a little bit. So this is a concept that took me a really long time to wrap my head around, because when I first started using Spark, I was pretty much brand new to programming in the commercial space entirely. So I didn't know really what any of these tools were. But over time, I developed a little bit of intuition on what's going on. So again, the cluster manager, it's an external service for acquiring resources. And the common ones you'll see out there, if you look on the Spark documentation, they have Standalone listed out, which is a prepackaged cluster manager that comes with Apache Spark. If you, after this, tomorrow, whenever, if you start playing around with Apache Spark, I recommend going in and trying to just boot up the standalone nodes to try to understand the process of how a worker node is booted, how a master node is booted, how they communicate with each other. But don't use that in production. So don't use standalone in production. You're not going to have a fun time with it. But it's great for playing around, which is exactly what I had on the slide. So yeah, don't use it in production. Use it for proof of concepts. Another one, which I've used before, is Apache Mesos. So a lot of the same developers for Apache Spark, including the person that I talked about in the beginning of the history lesson, also work on Apache Mesos, so they push this pretty hard. But Apache Mesos is the distributed system kernel for building distributed applications. It gives you fine-grained control into CPU utilization, resource utilization. So you can boot that up. I've ran an Apache Mesos cluster of 20 nodes on our own private data center. It's nice because you can run Spark right alongside all your other applications. It's a really great way for maximizing your resource usage. Again, it allows really fine-grained control over your resources. And again, it's really nice if you're managing your own resources. If you're not managing your own resources, if you're using something like AWS, I recommend one of these latter two. The first of which is Hadoop Yarn. This is another distributed resource manager. It's very similar to Mesos, but it's built to work well with the Hadoop family of tools. That's really where it came from. I think it started back when MapReduce was really big. It was built to help organize MapReduce. This is what Amazon uses for their EMR, Elastic MapReduce console system. They use Hadoop Yarn. And typically the big vendors, if you end up working with any of those, Cloudera, Hortonworks, DataStax, any of those guys, they're all going to push Hadoop Yarn as well. That's their preferred tool. This is a really nice tool. We never had any issues with it. If you're booting it up yourself, just be cautious. You have to boot up Zookeeper and you have to manage a bunch of other stuff along with it. But it works. Yeah, it's been around for a long time and it works. The last one, which is pretty interesting, is Kubernetes. Kubernetes is brand new. Andrew knows more about this than I do. It's a container orchestration tool. Do you want to talk about, because you've used this before?
Yeah, we've done some experimentation with it. It basically, on that Spark submit program, that's your driver, is that what you called it?
Yeah.
You pass it the REST API to Kubernetes, and then Kubernetes, like you said, that container, or that, what'd you call it? The cluster manager. Yeah. Kubernetes becomes your cluster manager, so that driver starts spawning pods in Kubernetes that function as your worker node. So yeah, all the like auto scaling and security properties that you already have on your Kubernetes cluster, they just work when you launch jobs against it. So.
Yeah, so I would say if you're in this boat, kind of the same boat as the Apache Mesos, where you have your own data center, you're managing your own resources, I would give Kubernetes a shot at this point. Just seeing how easy it is for people to use it.
Yeah, we liked it because we already have a bunch of work in Kubernetes. So when we want to run our Spark jobs, our cluster can just grow and run them and then shrink again.
Yeah.
Are you doing that in production?
No, we have some stuff in testing. Let's do that right now.
It's
I'm on a project that has to be delivered quickly and safely. It needs to be a very low risk project, and all our ops people are saying, "I'll do it on Kubernetes. We've got all this other Kubernetes."
Yeah.
And you go out to the site and it says in big bold letters there, "This is an experimental scheduler." And
yeah, it's only been
my most withering look I could give over the Zoom. It's one of those times I hate being a remote employee because I can't give them the withering look in person.
Yeah, I think it's experimental because it's pretty new, but I mean, it looks like it's pretty straightforward.
Yeah, it's been around since version 2.2, which is only 2 minor versions ago. So it is really new, but it seems like they pulled a lot of the same tools that they use for Mesos, the Spark library, and just plugged in Kubernetes. So I think it's one of the safer like experimental things.
Yeah, considering Kubernetes is only really 2 or 3 years old itself. So.
Yeah. But if you
I was told not to screw up and make the company close its doors, so we picked EMR.
yeah,
Probably,
yeah, EMR
probably not
is
a bad choice.
So, and EMR is what we use here at LifeOmic. Nice. All right, so RDDs and data frames and data sets. So I touched on this a little bit, but through the evolution of Spark, there's been 3 major API layers that have come out. The first one was RDDs. This is the one that was released with version 0.5. This is what the white paper is based on that they published back in 2012. So this is the core concept of Spark. So in RDD, it's a read-only collection of objects partitioned across a set of machines that can be rebuilt if a partition is lost. Right? So it's a really important concept. It's read-only, and it's partitioned across a bunch of machines. And if something gets lost, you can rebuild it. That was huge back in 2012 or 2011 when everybody was running MapReduce. You couldn't rebuild things if things were lost. You couldn't run iterative programs. You had to run single MapReduce things. So this is a really big concept. You can still use it today. A lot of the hardcore libraries are still running RDDs. They're all still all based on RDDs. So we'll talk about MLlib and Graphx and stuff at the end. Those are still mainly running on RDDs. So still completely valid, but it's a very much lower level, finer grained API. I wouldn't start there. Instead, I would start with datasets. So datasets came out with version 2, which is a really big step forward for the Spark programming language, the Spark framework. So a dataset, it's a distributed collection of data. It provides the same benefits of RDDs, strong typing, but it also runs on top of the Spark SQL optimized execution engine. So with datasets, what you can do with RDDs is you can write SQL-like expressions and interface with your data in a SQL-like way, but get the optimization benefits of RDDs, which is great. So especially if you really like strongly typed languages like I do. So if you try to create a data set, you'll see that data set object type. And then the third one, data frames. So data frames actually came before data sets, came in the middle. It was released with version 1.0. But data frames has kind of been replaced by data sets at this point. But it still has its niche use cases. So if you're familiar with R and Python, this is very similar to what you would get with data frames. It's a very similar kind of programming model. When you create a data frame, it doesn't have strongly typed values. Like you can't create an object and make that live inside of a data frame. It's just a row, and it's a row with different types on it. But it's great if you just want to pull a table out of a database and then interact with it in Spark. You're going to want to use data frames. So here's another way to look at all this. So 4 columns, version, API, use case, and abstraction. The top one there, data sets. This is what I would go to if you start working on Spark. Try out the dataset API. It's easiest to get familiar with. Maybe try out the data frame API. Then after you've been doing this for a while and you run into some really obscure use case that you can't figure out how to solve with data sets or data frames, then you look at the RDD API, but not until then. Any questions about that?
Question was when do you use data frame versus RDDs?
So if you need to do something with SQL, if you need to read data from a database and you want to use the Spark SQL API, then you're going to want to use data frames. If you're loading up text files and you want to use like a graph algorithm or one of the machine learning algorithms, then you'll probably have to look at RDDs.
Generally not really.
Yeah, generally not. I mean, I can think of one time, I've been doing this for 5 years now. I can think of one time where there was something in a Spark SQL API like a reduce by key operation. Yeah, It didn't work well in SQL. You ran into this?
I saw that there. The reduce by key is a Spark machine learning key. That's what's called. It's a kind of it's like a function type, right? So that you can use to improve by the data.
Yeah. Right.
Right.
Yeah. So it's very rare that I had to use RDDs, but yeah, there is a place for them. But I will say that all of the other libraries within the Spark ecosystem are moving to the Dataset API. They all kind of started when RDDs was the only option, but they're all migrating in the Dataset direction. So it's definitely the future.
Do I remember correctly that DataFrame is now a type alias for a data set of row? Is that correct? Okay.
Yeah, that's right. So libraries. So I've kind of been touching on this as I've been going. But there's a couple different libraries within the Spark framework. So there's Spark Core, right, which is the thing that has a Spark context and has all the hardcore stuff in the middle that's doing all the node communication and everything we've talked about so far. But there's a couple others. The big one, Spark SQL, which I've talked about a little bit. This is what provides the SQL API. So if you are working on a project where you need to connect to a database, you need to connect to MySQL or Postgres, you're going to want to pull in the Spark SQL API. And that's going to make it so that you can configure a JDBC connection, and then you can run Spark SQL, select star from whatever, and load all your data into Spark. It's super easy, super simple. It's the best thing to use if you're really working with any of these data sources listed, Parquet or C, JSON, any kind of JDBC. And it also has Hive support. I've never used Hive, oddly. I know a lot of people who have, but if you have Hive, if you've built out all your tables in Hive, there's support for that in Spark SQL.
That's our primary use case.
Okay, yeah. Yeah, so you'll definitely use that. There's all sorts of configuration stuff that you can do for Hive, but yeah. Another big one is Spark Streaming. This is kind of becoming outdated, but they're still working on it. They're still building it. If you have streaming data coming in, real-time data, if you're using Kafka or Kinesis or whatever, and you want to do if you want to do windowed analytics, if you want to say, what is the average number of users who have clicked on my website from this stream over the last 10 minutes, you could set up a Spark streaming cluster to do that. And that's where you need multiple computers to be able to do that operation, right? You could use Spark Stream for that. That's pretty much the only use case for it at this point. There's really better tools for any other type of streaming process out there right now. But it's still an option for you, especially if you set up your own Spark cluster and you have the resources there for you. Another big one, which some people here are probably interested in, is the machine learning library in Spark. So they've been working on this for a long time, and it's gotten pretty good. They have support for most of the common machine learning algorithms out there: regression, classification, clustering, all the statistics, really all the classical data science problems. They have support for it. It's built on top of Breeze, which is this Java linear algebra library. It's pretty performant. I've used it a couple times. I've always had a good experience with it. It's a nice framework, especially since they put in ML pipelines as a version 1.6, I think. That makes it really nice. You can build up a whole pipeline of machine learning parts. You can do feature training or feature extraction, and then do your classification and everything. It's really nice. Recommend taking a look at that. And then a little plug. So it's not here, but one of the engineers here at LifeOmic, Derek Miller, he's really big machine learning engineer. He knows a lot about TensorFlow, so he's built SparkFlow, which is TensorFlow on Apache Spark. I can't go on all the details of how this works, but basically, if you have TensorFlow and you're starting to run into problems where you can't fit it all on one machine, or you need multiple GPUs distributed across multiple machines, you can use SparkFlow. We're using it in production as part of our platform. It lets you distribute your TensorFlow applications across a bunch of different machines using the Spark infrastructure. It's really nice. And the last one is Graphx, which I've just started using recently for some knowledge graph processing problems. But if you have come to situations where you need to do like a page rank or you need to do graph traversals, the Graphx library is available to you. It has support for the Pregel API, which is an API that Google developed for doing all their search graph traversal stuff. It has support for that out of the box. I'm using it right now. It has pretty good performance. It's good. So any questions about this? Libraries.
When you read that data in DataFrame, right?
Yeah.
You just hold that data in memory, whole thing.
Yeah. So yeah, when you load something into a data frame, it's going to be in memory across all of your worker nodes. Now, depending on how you configure your Spark job, you can choose if you want that to be serialized in only memory, or both memory and disk, or just disk. I don't know why you would use just disk, but you can configure that as well. So some jobs, you want to fit everything in memory if you can. If you have the resources for it, put all in memory. This would be the fastest thing. But sometimes you don't. When I was at my last company, we only had 20 nodes, so we didn't always have enough room in memory. So then sometimes you have to serialize the disk, which has a performance cost, but it's all in memory on those worker nodes. That's the data frame.
How many of these libraries that you just talked about are also available for PySpark, or are they all Scala?
Spark SQL is the only one that's also available for Python.
Okay. Yeah, our data scientists are using that one.
Okay. Yeah.
They do a lot of these things that I think could be done with MLlib, and they're kind of allergic to.
Yeah, MLlib maybe.
All right.
I haven't checked recently, but there may be some support for MLlib.
Yeah, I'm on the ML team, but our team is kind of allergic to Scala. They want to do all Haskell, and then our data scientists, they're allergic to Scala. They want to do all Python.
Oh yeah.
So we haven't used MLlib yet, even though we're doing a lot of things that I think could be solved with it.
No, you know what? MLlib has to be supported in Python because our machine learning engineer who wrote the SparkFlow library, that's using MLlib's API, and it runs in Python. So, yeah, it's supported. I would say it's not as easy to iterate using Spark working on machine learning problems that it is to use the Python libraries. They're out there, especially when you're working on data sets that fit on a single machine. Mm-hmm. Usually, in my experience, it's been working with data scientists who develop something in Python or R, and then they're ready to take it to production, and then we convert it into Spark and productionize it. So that's a typical workflow. How much work is that? It's a fair amount of work. That's kind of what I've specialized in since I've been doing this. It usually takes me a couple of weeks to convert it. There's all the, you have to rewrite all the code, and then there's all the other things you have to think about, like distribution of the algorithms. Sometimes you have to reverse engineer those. That can take some time. Give yourself. Yeah, and then just some closing thoughts. I probably touched on a lot of these things, but in the end, when you're thinking about using Apache Spark, usually these are kind of the bullet points I go through in my head to figure out if it's a good use case or not. So Spark's a good choice if you have unknown input and output scaling requirements. So if you're processing data from a database that is growing all the time, Apache Spark's a nice option because you can scale with it. So I just ran into this last week. We have a database where we're getting clinical data, patient data. People are uploading data to it all the time. I was running a Spark cluster with only 4 nodes in it, and then I started getting out of memory errors. I just scaled it up to 8 nodes, and it worked fine. That was all I had to do to address the issue. It just scaled perfectly. So that's a good use case. Another one is if cron-based tasks are acceptable. So if you need to do something in real time, Spark is not your guy, right? If you use AWS EMR, it takes 10, 15 minutes just for the cluster to boot up, right? It's not a real-time processing engine. I know there's use cases out there where people put a front end in front of it for BI tools, but I personally would not do that. I would use a different thing like all those other distributed SQL processing tools that are out there. Use one of those. I wouldn't use Apache Spark. If you have complex transformation logic that fits SQL-like expressions. You were just mentioning one of these. If you have a big SQL script that's really hard to work with in SQL and it's just getting unwieldy, that's a good thing to put into Spark. You can put it in Spark, you can write it in Scala. That's a good use case. And then, again, if you should probably be comfortable with Java, Scala, or Python before you jump into this. So when is Spark a bad choice? So if you know your data set fits into a single machine, don't use Apache Spark. Use something else. I did this a lot when I was really fresh to programming. I just wanted to use Apache Spark, but don't do it. It's just a waste of time. Again, if you have real-time needs, don't put this in front of a REST API. And then, of course, if you don't have the computing resources or you don't have the financial resources to run Apache Spark, you know, it's distributed computing, so you're going to be running this on lots and lots of machines. You should think about that beforehand. Don't waste your time writing Apache Spark if you only have one computer. And then I thought I would just talk about a couple of real-world examples I've ran into in the past. So I have 3 different ones listed here. The search one is what I've been working on most recently at LifeOmic. I'm taking data, clinical data from a MySQL database, and I'm merging that with a knowledge graph, ontology data that lives in a Neptune database. And I'm using Spark to merge those 2 data sets together and then write them into Elasticsearch for a search engine. So Spark has built-in support for MySQL. I was able just to pull in the Elasticsearch REST API to do my writing to Elasticsearch, and then I'm still working on the Neptune part of it. But it works really nicely. That's the one where I just had to scale for main nodes, and it just worked. Another one that we're doing here, we're using Apache Spark. Ryan's working on this. We're reading genomic data, which is really, really big files. How big are they? Terabytes?
Terabytes.
Yeah, terabytes.
They're just freaking huge.
Yeah, so we can convert all those into Parquet, right? Yeah. And then we also join that in with data from MySQL, and we write all that into Postgres. We do upserts into Postgres from Spark. It works really nicely. So that scaling gives us the flexibility to manage those terabyte-sized files, and that uses Spark SQL. And then another use case I ran into in the past when I was at my last company was doing time series analytics. So this was an interesting one because we were reading data from like 6 or 7 different sources. We had Postgres, we had MySQL, we had Netezza. We had a team switch from Postgres to Greenplum halfway through a project. We had stuff from CSV, we had stuff from Avro, from Parquet. It was just all over the place. And we used Apache Spark to manage all those pulling data from all those different data sources. We got it in the Spark SQL API. We were able to interact with it in a common way, really sped up our development. And then we wrote it out to Parquet, which allowed us to do additional BI analytics on it. And then we wrote it out into Druid, which was a time series OLAP database. And we used Spark SQL for that. So that was actually a really, really good use case for Spark. Lots of nodes. So that's it. That's all I have.
How did you connect to the MySQL database? I mean, is there a ODBC?
Yeah, there's JDBC.
Driver, right? Or
yeah, there's JDBC.
Okay. And you cannot connect to any cloud-based database, right?
There's connectors to all sorts of databases.
Yeah, we actually connect DynamoDB in
Oh, you do? Okay. Perfect. Okay. Cool. Do you use any kind of gateway or something to connect, or is it just like normal ODBC or?
We just use the AWS SDK libraries for DynamoDB. We even hit some of our own internal APIs as well. So yeah, I think in the one job I'm working on, we do actually 4 of the above, and then we generate some pretty advanced SQL to bring it all together, and that's when we write it out to the Postgres.
You mentioned the streaming part of this had been surpassed by some other things. I know Apache Flink, that's really hot right now. That was streaming first. And my impression of things was those 2 libraries were kind of converging. So Spark, it started as the batch framework, and it's added all these streaming features and was catching up to Flink in that regard. And Flink started out as streaming, and they've been doing things a little bit better for these batch processing things. And now they're more interchangeable than they used to be. So if you don't think that Spark is good for streaming, would you say it's because Flink is better or because some other tool completely unlike it is better? What's the basis of that comment?
I personally just haven't ran into a use case where you needed a distributed processing engine to process distributed data. Like if I had real-time data that I needed to process, I'd put it in Druid, or I'd put it in a database that was performant for time series data. I wouldn't use Apache Spark to do analytics on it. I'd use some other kind of specialized tool. That's what I've ran into in the past. We have a lot of engineers here who've done a lot of real-time processing. Like you did all sorts of good stuff.
Yeah, we use Storm, which I wouldn't suggest.
Yeah.
But yeah, that doesn't scale well at all. So I think
I've heard that a few years ago.
Yeah, I moved off the team, but I actually think they were trying out Flake. I don't know how that went.
Okay.
I moved on.
Yeah, I think there's just some kind of like inherent problem with trying to use a distributed processing framework to solve time series data problems. Yeah. Any other questions?
I'll keep going.
Yeah, keep going.
Do you have any functional programmers here that look at Spark and are just like, that's a problem that I have at work? That's what we started as primarily a Haskell shop, and we use Scala. It's kind of looked down upon, just the things that you can't do in Haskell because we don't have time to write our own drivers for everything.
We don't have any hardcore functional programmers here.
Okay.
Pretty much everybody here has come from like a Node, Python background. There's nobody super hardcore. I'm not super hardcore functional programming either, but I've heard that before as well. I mean, Spark leveraged Scala to build its framework, so as a side effect to that, it has some functional paradigms, but it's not a functional language, right?
Right.
It just has some niceties.
If you want to learn Scala that way, like you say, there are a lot of people who are starting.
Yeah.
Is that Java is the basic thing to do, or I mean, Java is the mandatory to learn, or we can start from the basic of learning
For doing Spark or for doing Scala?
I think Spark is a complicated beast, so those three primary languages it has, Java, Scala, Python, be good at one of those and then learn Spark in that, because those all have first-class support. Now, of those three, Scala is far and away my favorite language, even though I'm a little bit uncomfortable with the way that it does side effects willy-nilly. You've still got better type system there in Scala than anything else. And I think that makes a big difference as your code gets more complicated. I find our Spark pipelines so much easier to maintain than our Python pipelines. But I don't want to take all the data scientists who are really comfortable with Python and know all the libraries in Python, trying to get them to rewrite everything in Scala doesn't seem like a very good use of time either. So if you've got people who are really good at one of those languages, that language is probably fine. And that's the best way to learn Spark, or else you'll be learning two things at once. And that's hard to learn two things at once. It's good to learn one thing at once. It's bad to learn zero things at once, then you're not progressing. Learning two things at once, that's hard. So try to learn one thing at once.
Roger, what do you think?
You want the stupidest question?
Yeah.
Okay. You can just say no, because I know the answer is no. But Yarn isn't related to the Facebook Yarn.
No.
Okay.
Yeah. Two completely different things. Yeah.
Okay. That's cool stuff, though.
Yeah.
I'm gonna run the Spark on iOS.
Let's see if I can.
Thank you.
Yeah.